Hello, I'm Hadley Arch. I'm an FTC alumni from 8581 Edificatores. I've been out of FTC for a few years. I think my last season was Rover Ruckus. And every year since then, I've kind of liked to make a video on the current FTC game and what I would do if I were going to make a robot for it. So, an initial design concept and a little bit of strategy. So, let's get into it. My initial thoughts for this game after watching the video and reading the game manual is that it's very similar to some other FTC and Vex games. So the most similar FTC games would be Skystone and Cascade Effect because you have to reach up high to score something. Similar Vex games would be Tipping Point, which seems very similar, where you have to, wait, no, not Tipping Point, In the Zone, where you have to score cones onto various different scoring areas. Some of them are tippy, these small rolling goals, or I guess I don't know if they were called rolling goals, but the ones you drag around with you. Then Tipping Point last year and Vex had very tippy goals, which seems similar to how the springiness of the poles that are used in Power Play. Additionally, there's Vex Skyrise, where you also had an unstable object that you had to stack on top of. The other image I added here that's not related to any of these games is I like they brought back this robot for the game animation. I think the circuits are a very nice addition to this game, Power Play. And it means you would really have to coordinate with your alliance partners and play real-time strategy tic-tac-toe against the opposing alliance. So I think that's a fun addition. I'm expecting to see a lot of double reverse 4-bars and vertical slides this year, probably more vertical slides than linkages, but I don't know. Because that's what teams have used to score up high in the past. The need to secure the poles while scoring seems like it'll be essential considering how springy they are, and so you have to hold them still where you're scoring so you can line up properly. I think agility will also be crucial. This is the most cluttered FTC field in terms of immovable objects that I can remember, ones that you can't really get around. And I expect defense will happen in endgame, particularly in a lot of blocking, maybe not as much pushing, but definitely some blocking. And so those are my initial thoughts on the kind of game. So getting into a little bit of the design that I came up with. The first thing I was looking at is, so what kind of paths will the robot have to move through? So I'm going to say you start here, and autonomous, you'll either go here, or maybe you'll go over here, depending on the randomization. Scoring cones, you'd go pick them up here, or you'd pick them up. I don't remember if you can pick them up in this station during autonomous, but maybe you can. So those would be maybe the places you would drive, and maybe just try and score in this square of scoring areas in autonomous to get as many cycles as you can in the 30 seconds. So that's what I was thinking for autonomous. Teleop, it seems you'd be moving a lot from over here, or more likely over here, and maybe going over to the other alliance's area to score on some of these. And so there would be a considerable path you'd have to take there. And I thought it was interesting in this game how you really just kind of move at right angles, and that there's maybe some curves, but there's not it's definitely, you're not making long arcs across the field due to the poles. So looking at endgame, I think the farthest distance you would have to travel to park in endgame would be, maybe say you were on the Red Alliance and for some reason you couldn't get in this goal, or this, not goal, but parking area. So maybe you have to drive all the way over here. And so I used this as the basis to come up with a drivetrain ratio on 100mm wheels to about 16:1 would give you ample time to get there in maybe under 5 seconds if you're a really good driver. And so that comes out to what, 1.7 or 1.8 meters per second. So I would definitely say you'd want to use aside from the 16-to-1 ratio, you definitely want to use holonomic drivetrains in this game over six-wheel drive or something similar, unless you had a turret. But honestly, I think the holonomic drivetrains would perform better. I think mehcanism will be the kind of gold standard for this season. Particularly, I also think, or to add to that, I think locking mehcanism would be a good option this season due to the defense and how it would give you the ability to push and resist being pushed while still having that agility. Swerve is a big resource-intensive drivetrain. I'm sure some teams will try it this year. I'm interested to see how it does. And then H drive and rocker H drive and ball drive, I'm not super confident that any of those would be the best option because you don't have the full power of 4 motors while moving in every direction like you do with maybe you don't have the full power, but you would use fewer motors and have less power in your drivetrain. Yeah, I think mehcanism is the way to go this season. So a little bit about the design I came up with. So I was looking at linear slides and double reverse 4 bars to start with, and I decided that there's a lot of moving mass to score that is not your scoring element. So these scoring elements only weigh 72 grams, which I believe is in between the yellow blocks, regular yellow blocks from last year, and the lightly weighted ones. So they don't weigh a whole lot, but if you're moving all of your slides up, so if you have a bunch of slides, you have to move the mass of all of those slides plus your grabber plus your cone here. And the same thing with linkage. You would have a very large structure, so this is not a very good representation, but you get the idea. And you would have to pick it up similarly. So you have to move all that. So what if I was thinking, how do you reduce the mass of what is moving up to the top where you score? So you can move this cone as fast as you possibly can, so super fast. So I was thinking about using, instead of having the slides come on up and down every cycle, instead you just have them come up at the beginning of the match and they stay up, and you use a timing belt and a shuttle similar to like a 3D printer to move the cone up and down. So here I'm going to start drawing the belt here, and so there's our belt in its fully extended position. So this is during the scoring position. I'll get to what happens at the beginning of the match later. And let's say you have a plate on there. So we'll put a plate of some variety, maybe aluminum or carbon fiber or plastic or something nice and light. And then you have a 3D printed part that would match the contour of your cone. So I'll move the cone in. And then a servo, which you'd want a lightweight but very strong servo, so maybe Savix micro servos or mini servos, or maybe the new Axon Robotics brushless servos. Shout out Axon, seems pretty cool. And so I'm going to draw, and then you'd use a linkage to grab onto the inside of the cone. So there's like I'm going to draw the hidden line here. So say that's the inside boundary of the cone. And so if you have a nice rubbery surface or some grippy surface on your 3D printed part here, and then you have a finger, which let's make the finger, I don't know, this color. And so you'd have your finger and it would grab the inside lip of the cone there, and maybe you'd probably put your really grippy rubber on there too, so you can pinch it really hard. And then let's draw the servo. Here is our servo, and then you would have a linkage that would connect here This isn't like an optimized linkage or anything. This is just kind of drawing it out. So you could move your finger in and out to pinch the cone. And then you would just move this light assembly of you'd have your belts. You'll need two for stability, which I'll get into here in a minute. And then your lightweight plate, 3D printed part, and servo, your little finger. So that's all you would move. You'd just be moving this belt and then that mass there and that, which is going to be significantly less than a huge linkage system or maybe a linear slide. So it would definitely make it so you could move that whole assembly faster, which is what you want if you're trying to score as many cycles as you can. So I'm going to move this down over here, move the cone. And so now I'm going to draw the linear slides that would extend this belt. So this belt in the beginning of the match, I'm going to draw this in a different color. So we'll draw this in pink. So you'll have your pulley down here and your other pulley will be right here. So these two actually move together. So in the beginning of the match, I'll initially draw the retracted slides. So here's our retracted slides. So maybe 3 or 4 stages, and you're connected to your pulley, and then your belt is totally slack, and this actually needs to move up. So right there, this is not to the correct length. It's just a representation. So your belt is attached to your plate, and then as these slides in their fully retracted state are here, and then you'd have your pulley attached here, and you'd have all this excess belt. So it wouldn't be like this loop doesn't get smaller. Not the ruler, I want the eraser. So wrong eraser. Segment eraser. There we go. So this would actually be like looped way down under here. So you'd have all this slack excess belt in your fully retracted position, and then as you move your linear slides all the way to their extended position, which we'll use a gold kind of color here. So here they are in their fully extended position, and that tensions the belt. So you're all the way extended and all the way retracted. Your belt's super slack in the retracted position, so you would need some kind of guide for your plate so that it remains in this initial position at the beginning of the match, and when it comes down after scoring up on the pole over here, let's draw our pole. So after it scores drops the cone over here, it would come back down here and slot in so it's ready to grab another cone. Additionally, you would have a limit switch or a Hall effect sensor down here so you could home it after you extend all of your slides here. So very similar to a 3D printer. And then this belt would just have to be routed in a way inside the robot so it won't get like super tangled, and you could have a little maybe kind of sheath at the bottom of the robot down by the drivetrain that it would pull out of. And you would use two of these belts. I don't know if you would use 2 linear slides, but you would definitely use 2 belts. So looking from a top view here, I'm going to draw our slides, our slide right here, and then we'll just draw something like that, and then our 2 pulleys, which would we say they were purple in their fully extended state, so we'd have our 2 pulleys that would be attached to the slides, and that way your plate has 2 belts to ride on, and it won't twist back or forth like that, which I'm going to get to a video of a very quick prototype, and we can see that that was definitely an issue, and so you would definitely need these 2 belts. I'll just draw the whole top view here for clarity. So here's your servo and your linkage, your little 3D printed part here, for your cone, your little mount for the finger or whatever. There it is. There's your finger. And then here's your, nope, wrong color, cone in red. Oh, no. So there it is, circular cone. So that's kind of the top view. This belt would be driven from this bottom pulley here by a motor, and we could throw that motor back here, so you'd have your motor for your linear slides, and you could just do continuous rigging or something. Just kind of that's how the continuous rigging works. And then you have your other motor that you would then maybe belt or chain or something. I'll make this a different color to your. We'll make it the rainbow color. Nah, let's go with orange again. To your pulley down here to move it back and forth. And so this could be a really low gear reduction on the motor that drives this pulley system that moves your cone up and down because it's so light. And so then you'd have your motor for extending these slides, which you could also extend those slides pretty fast at the beginning of the match. And then another something I was thinking is if you added a ratchet assembly onto this motor, then you would make sure your slides go all the way to their extended position and are locked in place so the belt doesn't lose tension if the slides start kind of falling down. So that way it's all set in for the whole match. So that was my idea for the scoring mechanism. And now, let's see here. I'll erase some of this and we can go over to the intake. So let's go back to the full erase. What I was thinking for the intake, which I think the intake for this this kind of system would be fairly straightforward. You just have to design it so that you avoid the linear slides and the belt path. So I was thinking you could just take, I'll draw this in dark blue. You'll have a wheel here, and then maybe a smaller wheel out here, and they would be sprung inwards, and you'd want to grab your cone and low to its full center of mass. So there's the tiles, and you drag it along the tiles to get it into position, and so it would just be kind of hugged into the robot like that, and then there would be another 3D printed backing of some kind here that it would rest against, and then these would both be powered by a single motor back here, both sets of wheels. So from a top view of just the intake, you would have your cone, and then you would have your little wheels and your medium wheels or whatever. And so it would push it back against this green plate here that conforms to the shape of the cone. And then we have our motor, which, I don't know, we'll just put it over here. And then maybe you have an idler here or something, I don't know. Some way to connect all of these together so you run them off of the one motor. And so that was my initial idea on an intake. And so that's kind of so there's your scoring mechanism for teleop, and then endgame, you just make a very similar capping marker, whatever they call them, a beacon, that's what they call them in this game, to the shape of this cone so you can pick it up and put it on top just like that. And then integrating this all into the drivetrain. I don't have a full picture of the robot here, but you kind of get the idea. You can integrate this and this into a robot. So those are the general kind of first ideas I had on scoring. So now here's a video I have that shows the concept behind the belts in a more physical sense. So there's the drawing, and here's a very rough prototype. So here's a very basic prototype of the belt assembly that would score the cones. So there's our little placeholder cone that's been grabbed. There's no servo there or anything. It's just a placeholder. And then this is the linear slides. So this is one stage, but really you'd want maybe 3 to 4 stages or maybe more, I don't know, to get up to the top height of that tallest pole. And so down here, this is where you would drive the belt. So there'd be a motor attached here. And you'd have an identical assembly just like this right next to it. That way you have the stability so that this doesn't fly all over the place as you're raising it, as you'll see it will. And so down here, this little piece that's attached to the belt that has the cone grabbed sits in like a slot or some kind of contained position when it comes all the way back down. And that way it starts here, and even though this whole belt is loose, it's still sitting in an appropriate position to start from. And then the rest of this belt in the beginning of the match, before you extend the linear slides, is just kind of bunched up back somewhere down low in the robot, and you could route it and maybe wrap it a few times. But if you push this all the way up, it'll tension itself, or that'll tension it, and it will come out smoothly. So if we move our slide up, in this case we just have one stage, but you'd move it up and now your belt is tensioned. So I can't do this very well with one hand, but you could move your cone up. Initially, like a 3D printer, you'd want to home it at the bottom so you know where it is. And then you could move it up to score your cones. So then you drop your cone off on top of a pole, and then you move it back down, just like that. And the entire match, you would leave this linear slide system up because you'd have no reason to retract it, and it would just cause problems with the belt tension. So there it is back in the grabbing position. So that's a very basic prototype of how the scoring slide and belt would work. So that was kind of the scoring slide and belt mechanism there, and thanks for watching. If you have any questions, reach out to me on Discord in the FTC server, and that's all I got. Thanks for watching, and I'm looking forward to what all the teams come up with this season.